Okay, so yesterday in class, or today in class if you're listening to this sooner, we discussed how to solve a determinant. Today we're going to use determinants and Cramer's rule, this is something new, Cramer's rule, to solve the solution to a system. So we already know some other ways to solve a solution to a system. We can do it with Gauss-Jordan elimination. We can do it with matrix algebra, x equals the inverse of A times B. Now, here's another way to solve for a system. So let's look at this 2 by 2 system that's expressed in variables. So if D, Cramer's rule, finds determinants, 3 different determinants, D of x, and D of y. And if I had 3 variables, there would be a D of z. So what do we find the determinant of? The determinant of D takes the augmented matrix from the left side of the equation. And A1, A2, B1, B2, that is your main D matrix. We know how to find the determinant of that, A1 times B2 minus B1 times A2. What D of x does is when I want to find this determinant, I need to change the matrix. And what do I change? It's D of x. So instead of the x row, I put in the answer, the column matrix, C1 and C2. And as you would guess, for dy, instead of the y, where the y variable normally goes, I replace that with the same C1, C2. Okay, so then I have 3 numbers, 3 determinants. I solve for x and y by saying for x, D of x divided by D is x, and y is D of y divided by D. So we need, if we're going to find the solution, we need all 3 determinants to solve for the entire system. Let's try it. So we're looking at this problem. It's a 2 by 2 matrix. It's a 2 by 3 matrix with the answer. So let's see the different D's. Okay? Determinants. So we're going to say what the determinant, the D is 3, 4, negative 2, 3. Okay. Well, let's solve for the determinant. The determinant of that matrix is, we'll just call it that, is 3 times 3 minus 4 times negative 2, which is 9 minus a negative 8, which is a positive 17. We found one determinant. Let's find D of x. D of x, let's change colors here. What am I going to change? In fact, I'll just change the one column. I'm going to replace that column. I'm going to keep this column, and I'm going to put in negative 6, negative 13. And I will find the determinant of that. The determinant of D of x is negative 6 times 3, this column, minus 4 times negative 13. What is that going to be? Well, this is going to be negative 18. 4 times negative 13 is subtract negative 52. When I subtract a negative, that it becomes a positive. So my total answer is 34. Because positive 52 and negative 18 is 34. All right, let's do it again. D of y. What is D of y? Well, again, I'm going to go back to my D matrix. I'm going to keep the x column. I'm going to replace the y column with negative 6, negative 13. Now I'm going to take the determinant of this matrix. The determinant of dy equals 3 times negative 13 minus negative 6 times negative 2, which is going to be 3 times negative 13 is negative 39. And then I have minus negative times a negative is a positive. So now you see I'm going to add these 2 negatives together to get negative 51 for my D of y. So what do I do next? All right, I've got all 3 determinants. So in order to solve for x, x equals the determinant of x, d of x over d, which I look at my numbers and I have 34 over d, 17. X, 1 divided by d, which is Cramer's rule. This is Cramer's rule, using determinants to find your system. Let's do it with a 3 by 3 matrix. Always fun, right? Okay, let's look at this for a minute. Let's see how we're the same. First of all, my augmented matrix for D is the coefficients in front of the variables. Remember, when you're doing this, you must have your equations in standard form, all the variables on the left and in the right order, and all of the coefficients on the right, the answer matrix on the right of the equal sign. So there's my D. What did I do with D of x? I replaced the column matrix, and I put it in the x column. I took that same column matrix with D of y and replaced the y column. And I replaced over here for D of z, the z column. So and then I'm going to solve for x, y, and z. So in idea, it's pretty easy. Let's do it. It takes a little bit. So the first thing, let's look at the question first. The question just says find x. They're not asking me to find x, y, and z, which I could do. They're only asking me to find x. So what do I need? I need the determinant d, and I need d of x. Okay, that's what we're going to do. So we're going to say, what is d? Well, let's write the matrix. Make sure everything is in order. X's, y's, z's, coefficients. And I have negative 2, 2, 1. Negative 1, 2, negative 1. 1, 1, 1. Remember, that is my augmented matrix for D. Now I want to find the determinant. With a system of 3, I need to write these two over again. The first two columns, negative 2, negative 1, 1, 2, 2, 1. Now we're going to go to our 3 colors. First we're going to circle our positives. I'm going to tilt the paper a little bit. So I'm going to circle my positive diagonals. Okay, those were my positive diagonals. Then I'm going to circle my negative diagonals. We're calling them 1, 2, 3. Negative, negative, negative. All right, I'm set up here. And I'm going to take my positives first. Equals, the determinant equals negative 2 times 2 times 1 plus 2 times negative 1 times 1 plus 1 times, I'm going off the page here, negative 1, 1. So that is the positive side. From that number, I will subtract this. 1 times 2 times 1 plus 1 times negative 1 times negative 2 plus 1 times negative 1 times 2. All right, squishing it in there. All right, so we go back to the positive side and we say, let's solve this. Negative 2 and positive 2 and 1 is negative 4 when I multiply that together. The second piece, I have one negative, so the whole answer is going to be negative, negative 2. One negative in the third section, it's just going to be negative 1. So let's just do this piece. This is going to equal negative 4, 6, 7, negative 7. Okay, now let's go to the other side. We're going to subtract. This is 2 plus 2, 2 negatives multiplied together, and this is only one negative, so it's going to be negative 2. So when I'm looking at this, I see that these are going to cancel, leaving me with minus 2. Negative 7 minus 2 equals negative 9. That is the determinant of D. Now we've got to do this one more time. We're going to say, what is D of x? All right, so we're drawing up our matrix. We're going to substitute for the x row the column, the answer matrix. So we're going to put 0, -5, and 8 in the x column. Then we're going to copy the other two rows, which are for y, 2, 2, 1. For z, 1, -1, 1. Okay? And now I have my matrix, d of x. I have to repeat the first two rows. 0, -5, 8, 2, 2, 1. Now I'm going to find a determinant, so I'm going to take my positive rows and my negative rows. Circling the positive rows and the negative rows. Very important to do it in color so you don't cover things up and not understand what you have. That's negative, negative, negative. All right. So I'm going to have my, let's draw a line there. I'm going to have a positive block. 0 times 2 times 1 plus 2 times -1 times 8 plus 1 times -5 times 1. That's the positive. Let's subtract from that these products. 8 times 2 times 1 plus 1 times -1 times 0 plus 1 times -5 times +2. Okay, work it out carefully, slowly. This just goes to 0, anything times 0. So we have 0. This is going to be negative. 2 times 8 is 16 times -1 minus 16. 1 negative minus 5. So that's my positive side. Then I'm going to subtract. This is 16 plus 0 minus 10. Because -5 times +2. Okay, so this whole piece is going to be +6. This piece is going to be -21 minus this piece. So I have a negative and a negative, which gives me a final answer of -27. All right, I'm almost there. Done my determinants. Using Cramer's rule now. The question was find x. X is equal to d of x divided by d, the two determinants. So d of x is -27, d is -9. When I take negative divided by negative, I get a positive. 27 divided by 9 is 3. So x equals 3. I could go on to find y and z, but at this time I'm not going to. All right, we'll see you in class.